Okay, 238. Report says the median credit card debt of American households is zero. We know that many households have large amounts of credit card debt. Explain how the median debt can nonetheless be zero. Uh, well, I just looked up online, just real quick search for the average credit card debt, and it says the average credit card debt in the United States from 2012, which is what just first came up, said it was roughly $15,000. Okay, so that was average. X bar, I'm on erase X bar. Average debt, $15,000. Credit card is $15,000 per family. Okay, now how could it be that the median is this? This says it's zero. Whether that's accurate or not now, I don't know, since this book was written around 2008-9. But it's significantly lower. How can that be different, or how could it be even close to zero? Well, remember, as we talked, the median is the middle of the middle 50% mark of people, so that half the population is above and half is below. Well, let's just look at a small data set. Here's a small data set: 0, 2, 3, 5, 8, 9, well, let's 10. Well, the median here, okay, is 5, right? And if I calculate the average, I could add them up and divide by 7 pieces of data to get the average, and we're good on that. How could I have a data set like this and have the median be 0? Well, what if my data set was like this? What if this was credit card balances in thousands of dollars, say? 0, 2,000, 3,000, 5,000, 8,000, 9,000, 10,000, and so forth. Well, what if I had this 0, 0, 0, 0, 4, 8, $9,000. So I have a bunch of people here, and I have, 1, 2, 3, 4 people have 0 balances, and then I have a 4,000, an 8,000, a 9,000 person, owing money. Well, what's the median? The median here would be 0 balance. So if I use the median in this case, I could say, hey, the median debt is 0. That sounds really, really good. But what's the average? The average would be 4 plus 8 plus 9 is 12 plus 9 is 21 divided by 1, 2, 3, 4, 5, 6, 7 was 3. And if this is in thousands, it'd be $3,000. So the average would be $3,000 per family credit card debt, while the median is 0. So you have to determine which is a better measure in this instance for the center of data if you want to talk about credit card debt. Oftentimes it depends on your perspective and what you're trying to do with it, but certainly the average is going to take into account these higher numbers. The median takes into account, hey, I've got half the population is below that number and half is above it. So you have to know the difference between median and mean and how they're calculated and what they do. Okay, on 239, we've got a standard deviation here. That measures the spread. So we've got 4 numbers from 0 to 10 with repeats allowed. What are 4 numbers that have the smallest possible standard deviation? How about this? 1, 1, 1, 1. What's the standard deviation there? S equals 0, because there's no spread from the average. X bar is 1. The average is 1 here. 1, 2, 3, 4 divided by 4 is 1. And the data is spread out from 0 units. Okay. Now, how about this? B. Choose 4 numbers that have the largest possible standard deviation from, and the numbers we're picking are from 0 to 10. So 4 numbers from 0 to 10 with the largest would be, well, I've got to have a 0 and a 10 in there to be the most spread out. What would be the next 2 numbers I could put in there to make the numbers most spread out? Well, it would be probably another 0 and another 10. You think? Okay, let's actually write them over here and see what we come up with. 0, 0, 10, 10, and we're going to calculate S. And then what about this? 0, 0, 0, 10. Which do you think is going to have a bigger standard deviation? Which set of numbers is spread out more from the average? Well, let's calculate this real quick. X bar here is 10, 20 divided by 4 is 5. X bar for the second one is 10 divided by 4 is 2.5. So which set of data is more spread out from this? Well, let's go ahead and calculate it. On here we're going to go, let's see, turn this on, stat. I'm going to clear my list, go up, clear, and then down. And I'm going to put 0, 0, 10, 10, and do stat, calc, one variable stat, and it defaults to L1. Go down to calculate, and of course I get my average is 5 and the standard deviation is 5.77. Whoops, so I hit too many buttons there. So this is 5.77, and then I go back to 0, 0. Let's go back to my list and compare it with the other one, and go 0, 0, 0, 10. What do you think that's going to turn out to be, more or less? All right. Standard deviation 2.5. Or average is 2.5, standard deviation is 5. So it's less spread out. And does that make sense? Did you, whoops. Did you guess right? Okay. Why is this data spread out more than this? Because you've got more pieces of data further away from the other pieces of data. Here you've got 3 lumped together, which is the average is 2.5. So you've got 3 pieces of data that are pretty close to the mean. Only one is far away. Here the mean's in the middle, and you've got 2 that are equally far away on each side of the mean that are 5 units away both sides. So this is why the standard deviation is bigger for that data set. Is there more than one choice for either A or B? There is more than one choice for A, of course. All 4 numbers are the same. For B, is there any other that's going to give you further away than 0, 0, and 10, 10? And the answer is no, because any other ones, you can't get further away from each other than zeros and tens. Okay, there you have it.